Hi, it's Miss Molesbury here. This is our next to last lesson of the school year, which is pretty crazy to think about. Hopefully you'll enjoy it. I really think solving log and exponential equations are some of the really fun types of solving we get to do. So I'll try to make it make as much sense as possible. So at the top of your paper, it shows you the two different ways that an equation might look. So there might be a log on only one side of the equal sign. If that's the case, we're going to rewrite it as exponential. So I'm going to put little notes here. Log on one side only means we rewrite as exponential to get it to something we can solve. If our unknowns are inside logs and the logs are on both sides of the equation, it's pretty cool as long as the base is the same, we can set the arguments equal to each other. So, and I guess on both of these say a single log and a single log. So a single log meaning there can't be multiple. If there are two logs on one side, we're going to have to talk about what property could we use to combine these to one logarithm. So let me go back to what I was saying. Single log on both sides means set the arguments equal to each other. So these are the two methods that we'll be using, and we'll decide on each problem. Would a property help us? Would rewriting it help us? And we'll go from there. Okay, so number one has the log base 2 of x squared minus 6x equals 4. Okay, there's a single log, only one, on one side only, so I can go ahead and move with this process of, I can't solve for x otherwise. Right now, the x is in the argument, so I can rewrite it as exponential. 2 to the 4th power equals, not a log, sorry, equals x squared minus 6x. 2 to the 4th, please be careful, it is not 8. It is 2 times 2 times 2, which is 8, times another 2. So 16 equals x squared minus 6x. Then I'm going to move everything to one side, so I'm going to subtract the 16 and factor. So to multiply to negative 16, but add to be negative 6, I get x minus 8 and x plus 2, and that gives me two solutions, x equals 8 and x equals negative 2, once I set those equal to 0. Now, before we box them both and get all excited, we should really make sure that they are not extraneous. Okay, so an extraneous solution here would not make the equation true. And if you think about log graphs, remember they're only existing when x is positive, but x is the argument. So 2 to the 4th power, or 2 to some power, will only work if the argument is positive. Any positive base to an exponent will always give me a positive. So what I'm trying to say here is that extraneous solutions they are any values that make the argument negative. So I'm not saying that negative 2 is extraneous just because it's negative. We have to go plug it back in and see if it's true. Because we know 2 to the 4th should be 16. Okay, so if I go I'm going to show you the first one here. Let's see, I guess I'll write it over to the side. If I do the log base 2 of 8 squared minus 6 times 8, you're using that answer in both places. If we want to know if it's 4, log base 2 of 64 minus 48, and 64 minus 48 is 16. So this works. 2 to the 4th is 16. It did not give me a negative argument. So I'm good to go. This was our check. Okay, let's check the negative. It could be more suspect here. So I have to make sure I'm going to square the negative and the 2. Sorry for my lack of space over here. Here we go. So log base 2 of positive 4, and then this is going to become a positive, negative 6 times negative 2. And again, I get log base 2 of 16 equals 4, and that's another true statement. So both of these work. We'll see some instances where they don't, and we will be checking. You don't have to check for extraneous in our exponential equations from last class, only in our log equations, since log is not defined over negative infinity to infinity. Its domain is just 0 to infinity. So we are going to check and make sure that the argument remains positive, or else we're going to have an extraneous solution. Okay, so let's work our way down the page. Number 2, I have log on one side only, but it's not a single log. So when you see 2 logs that are adding, think back to your log properties. We can use the product property, and we can say that this could be one log where the 5 and the x multiply together. Now it's a single log, and so I can rewrite as exponential. What's the base? Well, hopefully you realize this is a common log with a base of 10. So you can write the 10 if it helps you, but this is saying 10 squared equals 5x. So 100 equals 5x, divide by 5, and I get 20. So if you're checking for it to be extraneous, we can go plug it into the whole thing. You could use your calculator to check as well, or just go do a quick check. 20 is positive, so the argument would definitely be positive, and it would work. All right, let's keep going down this left side. We have the log base 5 of 45x minus the log base 5 of 3 equals 1. So again, only logs, oops, thought that was my highlighter. Only logs on one side of the equation. We do need to combine them with properties. So when 2 logs are subtracting, I can use the quotient property. So they're going to have the same base of 5 still, but it's 45x over 3. And you have options. You could leave it like that, or you can divide 45 by 3, which is 15. And now I'm ready to start at the base and rewrite it as exponential. So 5 to the first power equals 15x. So divide by 15. And reduce down to 1/3 is x. And this one, again, is not going to need a lot of work. You're just going to do a quick check. 45 times 1/3 would make my argument positive, and that's good. If you wanted to plug it back in and prove it with your properties, you can also do that. Okay, let's move on to the right side. I can tell this one's a little different because I start seeing more logs. So 4 said we have the log base 3 of x minus 4 plus the log base 3 of x plus 2. And I need to combine these as well. And I'll be careful here. I'm taking x minus 4, and it's going to multiply by x plus 2. So we are going to have to FOIL out, multiply out this expression and rewrite as well. So as I FOIL this, I'm getting x squared. In the middle, I'm going to have a positive 2x and a minus 4x. So I'm going to go ahead in my head and say that's going to make negative 2 once I combine the 2 and the negative 4. And then I'm going to multiply negative 4 times 2 to get negative 8. Okay, now we're ready. It's a single log. We're ready to rewrite it as exponential. So 3 to the third equals x squared minus 2x minus 8. 3 to the third power is 27. I'm going to subtract the 27 on both sides. X squared minus 2x minus 35. To multiply to 35 and add to be negative 2, I'm going to need negative 7 and positive 5. And then I'm getting potential answers of 7 and negative 5. So before we box them, we have to go back to the original equation and see if either of them would give us issues. You're just making sure the argument is not negative. So for 7, 7 minus 4 is 3. That would be fine. 7 plus 2 is 9. That would be fine. 7 works. Negative 5 is going to be a different story. Negative 5 minus 4 is negative 9. And we just talked about, or maybe that was a video I made earlier this period. I think so. This is my second video today. So we didn't just talk about in this video, but we just talked about, or we can talk about it now, base 3 of negative 9. This is not possible because this would be saying 3 to some power gives me negative 9. No power is going to change the sign of that base. So negative 5 is extraneous because it makes both arguments negative, even the second one as well. So that's how you'll know when something is extraneous. Let's keep going. 5 has logs everywhere, logs on both sides. I can tell there are definitely some properties to be used here. So on the left side, I see a 2 in front. I see the power property. So I'm going to have the log of x plus 1 squared. We can simplify that out or multiply that out. Then the second side has 2 separate logs that I can combine by multiplying their arguments. X times x plus 3. And now when the log is the same, think about what you're trying to do with an equal sign. With an equation, you're trying to make the 2 sides equal. So the logs are already equal. So our goal now is to just focus on the arguments. X plus 1 squared. And I'm going to go ahead and multiply this x squared plus 3x. Set those equal to each other. And this is what we have to solve. If we can make this statement true, then I know the original will be true because the logs are the same. If the bases weren't the same, we wouldn't be able to work through this the same way. It's not something we're going to do in Algebra 2. The bases will be the same. Okay, so let's work this out. I'm going to go ahead and multiply x plus 1 times itself. So I'm going to get x squared. In the middle, I'll get an x plus x, so 2x and plus 1. I'm loving this because I'm seeing that when I try to get the x squareds on the same side, they cancel. It makes my life easier if it's not quadratic. So 2x plus 1 equals 3x. I'll get the x's on the same side. Okay, so x here might be 1. let's make sure that it's valid. So this side would have 2 times the log of 1 plus 1. So if you wanted to do a check and actually write it out, we can do that. 2 times the log, 1 plus 1 is 2. And then the right side would have the log of 1 plus, well, let me move this all over. Oh, it'll be fine. Log of 1 plus log of, up here, x plus 3, so log of 4. And then think about our properties. We said the log, no matter the base, log of 1 is 0. So this is, and this 2 could be rewritten here as log of 2 squared equals 0 plus log 4. Both sides are going to have log 4 equaling log 4. True. So 1 is valid. It makes none of the arguments negative, and you can take it all the way down to fully simplified and make sure both sides are equivalent. All right, y'all, one more. Same rules apply with natural log. We just know that the base is e. So let's look at our left side. I need to combine these natural logs. Oh, one thing that always happens, sorry, let me tell you. One thing that always happens is people see log in the whole problem and they just decide, oh, I'm just going to get rid of all the logs. Okay, that doesn't work. It only works if you have a single log equaling a single log. So that's why we've been starting with properties every single time. So I can combine this into a single log by doing x minus 3 times x minus 2 bring down the right side, right? And I really can now I don't need the natural log any longer because I know that it's one single log on each side. If you want to multiply it out first and then drop your natural logs, that's fine. But I'm going to go ahead and just keep working it now. Well, I'll go ahead and, I guess, multiply it out. Sorry for being indecisive. X times x, x times negative 2. So I'm going to have a negative 2x and a negative 3x in the middle. So minus 5x and a positive 6 equals the natural log of 2x plus 24. Now it's very clear it's a single natural log on each side. So let's set the argument equal to each other. And let's get everything to one side. So I'm going to subtract the 2x, so minus 7x. I'm going to subtract the 24. So minus 18, the right side will be gone. And to multiply to negative 18, but add to be negative 7, I would need negative 9 and positive 2. Set it equal to 0. So x is 9 and negative 2. And then we'll be able to pretty easily check here. 9 would be 9 minus 3, that'd be the natural log of 6, the natural log of 7, natural log over here of 2 times 9, 18 plus 24. Yeah, this is all looking positive. We could work it out to make sure it's the same value on each side. 9, I'm going to go ahead and box. The negative 2, however, I can see right away there's an issue. Negative 2 minus 5 makes this argument negative, this argument negative. If even just one was negative, that's enough to determine that this is an extraneous solution. So, of course, like anything else, it's going to take some practice so you can see all the different types of problems, but these are the skills and processes that you're going to need to solve logarithmic equations. One more day of fun word problems will be our last lesson for the year. Okay, let me or your teacher know if you have any questions.